Is that finding an inverse function? Like the last three problems on the quiz type of thing? Yeah. Okay, so those are actually two different types of inverse questions, and so I can do the type from the quiz was I gave you an equation and then you had to find the inverse, and so that'll be one type of problem. And then a different type of problem would be if we gave you two equations and we asked you, are these inverses of each other? And you can actually solve those both the same way if you want to. Basically, you're just going to take an equation and find the inverse of it and then, check and see. So we'll take a look at the quiz number 26. And so that one was f of x equals 5x plus 13. So the first thing you do when you're finding the inverse is you swap where the x and the y letters are. And technically, this part is the letter y, right? So we're just going to flip-flop those two letters. So we do x equals 5y plus 13. And then you do need to keep going after that. You don't just flip the letters. You need to get the letter y by itself. So I'm going to solve for y. I'm going to minus the 13. And then I'm going to divide by 5. You can do a really big fraction. So if you do a really big fraction, it would be x minus 13 over 5, big fraction. You could also do little fractions. You could do x over 5 minus 13 over 5. You could even do 1/5 x minus 13 over 5. Those would all be considered correct answers. If you want to get super fancy, you can write it in functional notation. F negative 1 of x equals whichever of these that you chose. And then, so this is asking you to find an inverse. If it was asking instead, like, are these inverses? You could do the same thing. So we could give you this equation, y equals 5x plus 13, and then we could give you a second equation that was like y equals 5x minus 13. And then the question could be like, are these inverses? And so you could pick one equation and you could find the inverse of it. And then you would compare it to the second equation. And if they're the same, you would say yes. And if they're different, you would say no. So that's a different type of problem. If we give you two equations and ask you, are they inverses? Your answer for that problem would be yes or no, but you would also need to have the work to back up your answer. So you can't just say, yeah, sure they are. You would need to show us somehow why they are inverses. If it said, are they inverses, you would, so let me start one from scratch. If we had this, and then we had this, and the question could be, are they inverses? Oops, what is this? That's supposed to be a question mark. I don't know what happened. Then what you could do, you could choose one of them. You could actually find the inverse of that one. And then after you have found your inverse, you can compare this inverse with the second equation. And if the inverse that you found is the same as the second equation, then you would say yes, they are inverses. And if the inverse that you found is different than the second equation, then you would say nope, they're not inverses. Okay, cool. So that's one way to do that. The other way would be composites, but I don't want to get too crazy with the many different methods tonight. So if you want to see composites, I can show you that instead. I do just want to do one more. For this one, again, we're going to swap the x and the y. And then I wanted to do this one specifically because I wanted to remind you guys that when you take a square root or anything with an even index, you always want to put a plus or minus symbol in front of it. So when you square root a problem, there needs to be a plus or minus sign. That is specific to anything with an even index. So a square root, which is just a regular radical, right? A fourth root, a sixth root, those would all need plus or minuses in front of them. If you do any other type of radical, like if you do a fifth root, which has an odd index, you do not need the plus or minus sign in front of it. You can just put the fifth root. All right, I did see we had another question, problem number 9 from the quiz, so let's take a look at that. And on these problems, there's kind of this 3-step questioning process that I ask myself while I'm doing these problems. And, you know, if I ask myself these questions in a certain order, I can get to my answer a little bit quicker. This is a fraction, and it's no adding or subtracting. So these are the questions that I ask myself when I have a fraction that has no adding or subtracting. And first I ask myself, can I simplify the actual fraction? So that's like looking at the numbers 7 and 36 and asking myself, does 7 over 36 reduce? Does it simplify? And unfortunately on this problem, the answer is no, it doesn't. Sometimes though, you can simplify the fraction and that might be the only thing that you have to do. Okay, so after you try to simplify the fraction, and maybe you succeeded and maybe you didn't, regardless of if you were able to simplify or not, the next thing you should do is you should ask yourself, can I simplify the radical? So that's a little bit different. That's where we do our factor trees to see if I have enough of the numbers to get out of the radical. And so on this part too, you want to split it into a top radical. And I didn't do the 7 because 7 is prime. And the bottom radical. For 36, we end up with 2 number 2's and 2 number 3's. You could also have kept it as 2 number 6's instead if you wanted to. Either way, since this is a cube root and we only have numbers that are being squared, 2 squared and 3 squared, or if we look at the bottom one, 6 squared, and we don't have anything being cubed, nothing can simplify out of the radical. And so now we're to our last step, our last option. If you've tried everything and you still have a rad underneath the fraction, then you need to do what is called rationalizing. Rationalize the denominator. And this is where you multiply the top and bottom of the fraction by some extra numbers so that the bottom of the fraction will not have the radical symbol anymore. And so since we have a cube root, we want all of our numbers to be cubed. So right now I have 2 number 2's, that's like being squared. I need a third number 2, so that would be like being cubed. Same thing with this number 3. I have 2 number 3's, but I'd like to have 3 of them, so I'm going to put a third number 3. And then whatever you do to the bottom, you have to do to the top as well. Okay, so now on the bottom, I have 3 number 2's, which means I have the cube root of 2 to the third, which turns into just a regular number 2. Same thing with my 3's. I have 3 number 3's, or 3 to the third, and so that's going to turn into just a regular number 3. And I would, for a final answer, actually multiply those together to make a 6. On the top, I don't have 3 of a kind of anything. I actually have just 1 of each number. And so they are all going to stay inside the cube root. And I'm going to multiply those together. 2 times 3 is 6, and 6 times 7 is 42. And so my final answer for this one, it's the cube root of 42 on top, and then just a regular 6 on the bottom. Now, if you had written it as this bottom version where you had 2 number 6's, then I would need, you know, that third number 6 so that I have a 6 to the third. And I would have to do that on the top as well. You end up with the same answer, right? Because you're still doing 7 times 6. And you have 1, 2, 3 sixes. And so that turns into a regular 6 on the bottom. All right, I'm going to try to keep track of what we've done. And so hopefully we don't double up on anything. And that way we can answer as many questions as you guys have. Okay, so that was number 9 from the quiz. There are some more. I know my students on our test review, there's definitely more problems like that. I'm going to assume everybody's test review has more problems like that. So if we need to see more like that, let me know. And then we had a question 23E on the quiz. So let's do that one next. (23E). And so on 23E, I actually did that almost as 4 separate problems. So the original was f of 3 times, it's a closed circle, that's a multiplication symbol, g of 2, and then this is minus 4 h of negative 2. And so what I kind of did off to the side is I started by finding out what is f of 3. And I did it very far off to the side. I almost would have even the quiz was kind of tight in that section, and I would have asked for a piece of scratch paper so I could do it somewhere else. But so I'm going to start by finding f of 3. So I need to do 3 times 3 squared plus 10 times 3 minus 8. So that's 3 times 9 and 30 minus 8. So that's 27 plus 22, and that is 49. So f of 3 is 49. So then I went back and right underneath my f of 3, I wrote a 49. This closed circle again means multiplication. And then I went back to my scratch paper, and the next thing I did was I found g of 2, because that's the next thing that happened in the problem. And so g of 2, so the g function is 3 times 2 minus 2. So that's 6 minus 2, or 4. So then underneath my g of 2, I wrote the number 4. This is a subtraction sign, and then it's 4. And since the 4 was right next to the h of negative 2, I'm going to end up multiplying it by whatever h of negative 2 is. And that's the next thing that I'm going to do. So again, over on my scratch paper, I tried to figure out what is h of negative 2, and so that would be 4 times negative 2, or negative 8. So this is negative 8. All right, and now I have an order of operations problem. I'm going to do 49 times 4, which is 196. This was subtraction, and I'm subtracting, and I have this negative over here. So those are going to cancel out to be a plus sign. And then 4 times 8 is 32. And then 196 plus 32 is 128. And then that's the final answer for that problem. We did number 26 on the quiz already. I can backtrack a little bit while I try to find what the next question is. Number 26, actually the very first one that I did, you're going to swap the x and the y, and then you're going to solve for y. And I wrote like 3 different ways that you could figure out that, or that you could write that answer. So if you look down here, I have option 1, option 2, and option 3 for number 26. 35. All right, next we're going to switch it up, and we're going to switch over to the review sheet. We had a question about number 35, so let me find a blank whiteboard and we'll do that problem next. So this is the review sheet that I gave my students. I'm not sure that it's the same one that you have, so if you are looking at 35 and it looks different, I apologize, but it's still good for us to do this problem. Okay, so on this one, we need to know our rules of exponents, and so one of our rules for exponents says if you have a power to a power, you're going to end up multiplying those together. So in this problem, I'm going to multiply 1/2 times 3. I'm going to write it as 3 over 1 so that they're both fractions. And when you're multiplying fractions together, you're just going to multiply straight across. So I'm going to multiply the 1 times the 3, which is 3, and the 2 times the 1, which is 2. And actually, that's all you needed to do for that problem. So the answer to number 35 is q to the power of 3 over 2. All right, next we had a question about even, even, odd. And so I'm going to switch it back up to the quiz for that question. And we're going to specifically look at problem number 3 from the quiz because that problem did need absolute value bars in it. So let's take a look at problem number 3. Okay, so the even, even, odd thing is if your if your original problem has an even index, and then you have a variable, it doesn't matter what the variable is, but the variable also has an even exponent. And then when you go to write your answer, if that exponent changes to an odd number, then you need absolute value bars. So that's the even, even, odd. So an even index, an even exponent, but then when you write your answer, it turned into an odd exponent. So taking a look at number 3, the answer was 2a squared b c to the 5th. Okay? And so then what you want to do is you want to look at each variable individually. And so starting with my letter A, so first of all, it's really important that this problem has an even index, right? It's because it's the number 6. So this number is even. And so that's this even right here. Okay? And then when we look at the letter A has an index of 12. That's also an even number. That's this one right here. And then when we look at the answer for the letter A, it's a 2, which is an even number. Now for the absolute value bars, that would have needed to be an odd. And so the A is even, even, even. So we don't need the bars around the letter A. Next, we can look at the letter B. The letter B, everything will have an even index because it's 6 is the index. But the letter B has an even exponent. It's the number 6. And then in my final answer, technically, this is a b to the 1st. And 1 is an odd number. So my letter B would need absolute value bars around it. It went even, even, odd. All right, and now our last letter is the letter C. So again, we have an even index because everything has an even index on this problem. The letter C also had an even exponent. It was the number 30. So even, even. And then my final exponent is the number 5, which is odd. Even, even, odd. So my letter C actually should have also had absolute value bars around it. Now if you have 2 variables that need absolute value bars, you are allowed to put them both inside the same absolute value bars, and that would have been okay. You should do this anytime you see variables in a problem. And then again, you want to look at every variable individually. And I would recommend doing like what I did right now, where you find the answer first. And after you've figured out what the answer is, then you should go back and try to figure out, okay, do I need absolute value bars? Just a little side note on question 2 and question 1 actually as well. You can try this even, even, odd thing, but question 2 has an odd index and you need an even index. So if you have an odd index, you will never need absolute value bars. And so you can do a really quick check on question 2 and say, oh, this is odd. I'm not going to need absolute value bars. And then one final thing, don't forget that square roots technically have an even index because it's a 2. So anytime you have a square root, it could be the even, even, odd rule. All right, I hope that explained that. All right, Lizzie, I don't think I have the same review sheet as you because mine only goes up to number 50. So if you are able to type up what question 51 is on the review sheet, that would be very helpful. And then I'm going to go back and we just did the even, odd. So the next question in the list of questions, and you guys just keep on typing them, that's fine. But the next one on the list was number 20. So that's what we're going to do next, number 20 on the quiz. All right. Thank you, Lizzie, for typing that in there for me. Okay, so on this problem, it's really important that the square root that has a bunch of stuff underneath it is all by itself on the right-hand side. So once you have a square root with the bigger square root, right, square root of x minus 4, once that's all by itself, then you're ready to square both sides. So right now I'm going to square both sides. Now on the side where there was a very large square root that took up the entire side of the equal sign, the square and the square root can cancel. You guys are very distracting. And so when those cancel, we just get x minus 4. Now on the other side, this square root sign, it doesn't take up the whole side of the equal sign. So I can't cancel the square and the square root. Instead, I need to figure out what the square root of x minus 2 squared is. So I'm going to multiply it by itself. And you can either do FOIL or the box method. I'll show both. If you have me, you know I love the box method. But just in case you like foiling, so you're going to do rad x times rad x, which is regular x, because it becomes the square root of x squared, and that'll cancel. And then rad x, oops, that meant to go further, times that negative 2 is negative 2 rad x. Negative 2 times rad x, again, is negative 2 rad x. And then negative 2 times negative 2 is positive 4. If you like the box method, you're going to put rad x minus 2 and then another rad x minus 2, since we're multiplying it by itself. And then a square root of x times another square root of x. That, again, it's technically, right, the square root of x squared, but that's just x. So that turns into x. This is negative 2 rad x, negative 2 rad x, and positive 4. And so what happens on the left-hand side, you end up with x minus 4 rad x plus 4. Okay, now I really want to get that rad x by itself, since it still has a square root sign in it. Oh, okay. I was wondering, oh wait. Oh, minus 1 after it. Okay, got it. Since there's still the square root of an x in this problem, my next step is going to be trying to get that square root of x by itself. And so I'm going to subtract the x. And very conveniently for us, when we subtract the x, it's x minus x, and those fully cancel, which is really nice. Actually, it makes the problem significantly less complicated. Next, I'm going to take the plus 4 and I'm going to minus it on both sides. Now for that one, the positive 4 and the negative 4 cancel, but a negative 4 and another negative 4, those don't cancel. Negative 4 and negative 4 makes negative 8. I'm going to divide by the negative 4 to get the rad x by itself. And as a final step, I'm going to square both sides to get rid of this square root, and I now have my final answer. My final answer is x equals 4. It's always useful, especially if you have extra time on your test tomorrow, to take this and plug it back in to the original problem. Just make sure that it works. So this would be 2 minus 2, and this would be the square root of 0, and 2 minus 2 is 0, and the square root of 0 is 0. So that's good. All right, that was number 20 on the quiz. The next question was on number 17. Okay, so number 17, we have x to the power of 4/5 and then divided by x to the power of 1/3. It's very important that the big numbers, the bases, are both the letter x. That means I can combine these together. One of our rules for exponents is if you have a fraction like this, then you can subtract your exponents. And so in this problem, I'm going to take the top exponent 4 over 5, and I'm going to subtract the bottom exponent 1 over 3. When you're adding and subtracting fractions, you need a common denominator, so that would be 15. I'm going to multiply the first one by 3 and the second one by 5. And so I'm actually going to subtract 12 over 15 minus 5 over 15. And when you're subtracting fractions, you only subtract the top numbers. 12 minus 5 is 8 over 15. 7? 7. Sorry, guys. It's late. 7 over 15. And 7 over 15 does not simplify. And so this would be my final answer. Since we didn't tell you in the directions what format to write that in, you also could have written the 15th root of x to the 7th. That also would have been appropriate. And that's number 17. All right, next we had a question, number 9. Ellie, I want to say you're my student. I'm hoping that you are the Ellie that's my student. And so we'll do question 9 from my test review. If this is not the right question, please let me know. Fourth root, 9, 8 to the third. Okay, and then this one is very similar to number 9 from the quiz that we were doing earlier today. So I have my 3-step process. First, can I simplify the fraction? And the answer is no. 8 and 9, I can't simplify that. Those don't reduce. They're even and odd. It's not going to work out. And so second question, can I simplify the rad at all? And so this is where I do my factor trees. I really hope, because this is actually going to help you with next chapter as well. I hope that you are all getting very comfortable with 8 factoring into 2 times 2 times 2. That is going to happen, oh my gosh, so many times in our next chapter also. And then I like visuals, so for the 9, I'm going to make it a 3 and a 3, and I'm going to write out all 3 letter A's because I like the visual of it. And so now that I can see all the numbers, and I'm a 4th root, so I need to have 4 of the same number. I need something to the 4th power. And looking at all these numbers, I don't have anything to the 4th power. It's not there. And so I'm at my last ditch effort, which says if I still have a rad on the bottom, I need to rationalize. Sorry, those don't look like actual words, guys. Rationalizing is when you multiply by some extra stuff until you get what you need. So it's again important to notice that this is a 4th root, so we need 4 of a kind. We need something to the 4th power. And so looking at my denominator, I've got 1, 2 number 3s. I want a total of 4, so I need 2 more of them. 3, 4. And whatever I put on the bottom, I put on the top as well. I also want 4 letter A's, and right now I only have 3, so I need 1 more. And whatever I do to the bottom, I do to the top as well. Remember that the purpose of doing that is, on the bottom, to get rid of the radical. So I now have 4 number 3's, or a 3 to the 4th. And the 4th root of a 3 to the 4th is the number 3, with no more radical sign. I also have 4 letter A's, or a to the 4th. And the 4th root of a to the 4th is a. And so now I have no more radical on the bottom, which was what I wanted. I want no radical on the bottom. Looking on the top, I don't have anything to the 4th power. I have 3 number 2's, 2 number 3's, and an A. And so I'm just going to multiply those all back together. This is 8. This is 9. 8 times 9 is 72. And then I need the A at the end. This cannot simplify anymore because 72a is underneath the radical, but 3a is not. And so inside numbers and outside numbers cannot simplify, and this would be my final answer. All right, that was number 9 on the review, on my review sheet, which might be different than yours. Still good problems. All right, my next question was on 24D from the quiz. So let's switch back to the quiz. All right, 24D says F composite H of X. And so I'm going to write them down on here. F of X was 3x squared plus 1, and H of X was x minus 4. I'm not going to write down the G of X because I don't need it for this problem. This problem does not have the letter G written anywhere in it. So this one has an open circle. That's very different than the one of these that we had done earlier. And so an open circle means take this thing, this H of X, and since it's H of X, I'm going to take it exactly how it is. So I'm going to take x minus 4, and we're going to plug it in to the f function. So I'm going to take the x minus 4, and I'm going to plug it in where this letter x was. And so I'm going to remove the letter x. I'm going to keep the number 3. And then where the letter x was, instead of an x, I'm going to put the x minus 4. And then I'm going to keep writing the rest of the problem. So there was a squared here, and then plus 1. And then you need to, simplify this out. So don't forget, you should do this part first, x minus 4 squared. And x minus 4 squared is x minus 4 times another x minus 4. And you can FOIL or box that. When you're done doing FOIL or box, you're going to get x squared minus 8x plus 16. Okay? And then the next thing you're going to do is you're going to distribute the 3 into that trinomial that you got. And then the final thing you're going to do, we have this 48 plus 1, which are like terms, and so we're going to add those together. And then this would be my final answer for that problem. All right. We are up to number 44 on the review sheet. Andy, if these problems that I'm doing from the review sheet are not the same as your review sheet, then I might need you to type up what number 32 looks like. If the problems that I've been doing are the same as the ones that you have, then we're good. I just want to make sure I have the same review. All right, so 44 actually has 2 parts. Oh, awesome, perfect. So they gave us f of x is 2x plus 7, and g of x is negative 5x minus 1. And so the first part wants you to do, and this is very similar to the one we just did, the composite of f composite g of x. And so in this part, they want us to take the g function, which is this, and they want us to plug it into the f function. So we're going to take that thing and we're going to put it here. And so I'm going to erase the letter x, and in its spot I'll put the other thing. So it's 2, and then instead of the letter x, I'm going to put negative 5x minus 1. And then after that there was a plus 7. And then you simplify. And so this is my first answer, negative 10x plus 5. They did want you to do it a second time, but this time they wanted you to do g composite f of x. And so for that one, they wanted you to take the f function with the x that was right here and plug it into the g function. So now we'll be getting rid of that x over there. And so we had, oh, oops, just kidding. We're plugging it into the g function, into this one. So the g function starts with a -5. And then instead of my letter x, I'm going to write my f function, my 2x plus 7. And then I finish it up with that -1 that was at the end. And then we go from there. And so the answer to the second half of problem 44 is -10x minus 36. All right, Lizzie, we are up to your problem, which was number 51 on somebody else's test review. So if you are not my, or if you are my student, we don't have this test review, but this is still a good problem for us to practice. Okay, so it looks like that one says, we're going to find the second one, h of x is 2 to the power of x minus 1, and they want us to find h of -2. And so that means we're going to plug in a -2 for the x. We're only going to plug it in on this side, right? So h of -2 means 2 to the power of -2 minus 1. All right, so one of our rules about exponents says if you have a negative exponent, you're going to take your problem and you're going to make it a fraction. And when you make it a fraction, the exponent can become positive. So since this is a negative exponent, I'm going to make a fraction. And when I do that, I can make it a positive exponent instead. Next, I'm going to figure out what 2 squared is. And I'm going to leave that on the bottom of the fraction. And then as we talked about earlier today, we need common denominators so that we can subtract fractions. So I'm going to multiply this 1 by 4. So that's 1/4 minus 4/4, which is -3/4. So hopefully that's the answer you were supposed to get on that one. All right. Awesome. Yay. Okay. So Lizzie, thank you. Question number 18 on the quiz. Looks like our next problem. I am trying to go in the order that you guys typed these in. If I accidentally skip a number, let me know. Just type it in again and we can go back and do it. So I think I said we're on number 18. We're going back to the quiz. Everybody should have the same quiz. I'm like 100% confident that we all gave the same quiz. All right, so number 18. And we did a problem like this earlier today. This is the rule that says a power to a power is a multiplication problem. So I'm going to multiply 5/6 times 2/3. And when you're multiplying, there's 2 different ways you can do it. You can just multiply straight across. And so that would be 5 times 2 is 10, and 6 times 3 is 18. And then if you can simplify, you should always simplify if you can. And so I would get this answer. The other option would be, since it's a multiplication problem, we can do cross-canceling. So you can cross-cancel the 2 and the 6, and that'll leave me with a 1 and a 3. And then I would multiply straight across. So now I'm doing 5 times 1, which is 5, and 3 times 3, which is 9. When you're multiplying, you do not need a common denominator. And if you do have a common denominator, you still have to multiply them together. Either way, this is my answer. It didn't tell you what format to write it in, so if you had wanted to write it as the 9th root of z to the 5th, that would also be okay. Sometimes we even do the 9th root of z to the 5th out here. That would be okay as well. So that was number 18 from the quiz. All right, looks like we're up to number 22 from the quiz. Okay. So on this one, similar to number 20 that we had done earlier tonight, it's really important that the radical is all by itself. So there's no numbers or letters on the left side of the problem that are not underneath the radical symbol. So that's really, really important. And once the radical is by itself, you can square both sides. Please notice that I'm putting them in parentheses so that I know that I'm squaring the entire thing. On the left side, since the entire thing was a square root symbol, you can just cancel those out, leaving us with the 3x plus 7. On the right side, I will need to actually square that out. Now, when it's an adding or subtracting problem, and we've done a couple like this today, you do want to write it out twice, and you're going to either FOIL or box it. And when you're done doing FOIL or box, you're going to get x squared plus 2x plus 1. I feel like I wrote that down wrong, guys. Just kidding. Hold on, let me fix it. It was actually an x minus 1, not an x plus 1. So let me change all those to minus signs. That one's not going to want to go. Come on, there we go. And this one. And that's going to change this also. No. No. Okay, wait. I don't want to do that. I want to do this. Perfect. Okay. Sorry. These were minus signs. Minus, 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 and then that makes this a minus as well. All right. Now, we have an x squared in this problem. Whenever you have an x squared, you need to make the entire equation equal to 0. And so I'm going to minus the 3x so that it goes away. And I'm going to minus the 7 so that it also goes away, so that now on the left-hand side, I have the number 0. So anytime there's an x squared and in an equation, you want it to equal 0 so that you can solve by factoring. So here I have a trinomial. We're going to solve this using Xbox. So I need two numbers that multiply to make -6 and add to make -5. Those two numbers are not 3 and 2 because to get a -6, I need a negative number and a positive number. So I actually need numbers that subtract to make 5. And so the numbers are going to be 6 and 1. -6 times 1 is -6, and -6 plus 1 is -5. So just, be a little bit careful with your factoring. So now I have this. And then when I solve, I get +6 and -1. Now on this problem, and this problem especially of all of the problems on your quiz, because there is a letter that is not under the radical symbol, you have to check your answers because it's possible that you will get an answer that's not really an answer. That is called an extraneous solution. Sorry. So we're going to check now for an extraneous solution or an extraneous answer. And if you have an extraneous solution, it does not get written on the answer line. So I'm going to move to a new screen to do that. My original problem was 3x plus 7 equals x minus 1. And I need to check x equals 6, and I need to check x equals -1. And so I'll start with 6, and we're plugging them into both of the x's. 3 times 6 plus 7, 6 minus 1. It's 18 plus 7, 5. Square root of 25 equals +5. We're good. 6 is a good answer. Next, I'm going to check -1. So 3 times -1 plus 7, -1 minus 1. It's -3. Oh my goodness. -3 plus 7 equals -2. That's the square root of 4 equals -2. Now that is not correct. The square root of 4 equals +2. And so since I got a square root equal to a negative, we're actually going to say -1 is not an answer. And, on the quiz tomorrow, or I'm sorry, on the test tomorrow, right? When we're grading your test, on this question, we would have wanted to see both of these written in your work area, but on the answer line, you would have only written the number 6. So make sure to check for extraneous solutions, and you know, if it doesn't work, don't write it on the answer line. You can leave it in the work area, just don't write it on the answer line. All right, I already forgot which one that was. Number 22. Okay, 22. Next is question 14 on the quiz. Hayden, we did already do number 27 from the quiz. So if there's extra time, I will do it at the very end of this session. I don't mind doing it again. It didn't take too long to do, so I think we can squeeze it in at the end of the session. If not, you can always watch the recording, and it should show up there. I already forgot which one I said we were going to do. 22, 14. All right. Okay, so on this one, they wanted us to change it from radical form to exponential form. And so there's some things to remember. When you have a rad, the index becomes the bottom of a fraction for an exponent. And if you have a rad of something that already has an exponent, the index still goes on the bottom of a fraction, but the exponent that you already had, that goes on the top of the fraction. So those are the rules that you need to know for this problem. Now, because there's multiple things underneath the radical symbol, everything underneath the radical symbol is going to get a fractional exponent. The 3, the 6, the y, and the z. So it's very important that we give that fraction to all of the things, everything individually. And it's an 8 is going to go on the bottom of all of those fractions because it was an 8th root. Now, if we look at the number 3, the 3 did not have an exponent, or technically it had an exponent of 1, so I'm going to put a 1 on top. For the letter X, I had a 6. For the letter Y, I had a 5. And for the letter Z, I had a 4. And then for a final answer, if you can simplify any of those fractions, you should. You do want to leave them all separate fractions. And this is the final answer that we were looking for. This was number 14 on the quiz. No, it's just, Carlo, it's just different. We use different letters to mean like, here's one equation. Oh, now I'm going to use a new equation. I'm going to give it a different name. So that's why it switches from F to G. It's just a way to like differentiate between which one is which. It's like giving people different names. Okay, Andy, I am up to your question number 32 on the review. So let's do that one. Okay, so question 32 is 4/9 to the power of 3/2. And so for the exponent, since it's a fraction, and we kind of just talked about this on the last problem, but we went the other way. Since it's a fraction, I can write that as a radical. And so I'm going to put the whole thing under a radical symbol. 4/9. And since the denominator was a 2, it's a square root. So I can just write a normal radical symbol. If you want to, you can put a little 2 in here to remind you. And then the top number, that's going to stay an exponent. Now, when you're doing problems like this, I always recommend that you do not put the exponent underneath the radical, because that's going to make your numbers like really big. So instead, what I would do is I would put that top number, the 3, I would put it on the outside. Next, what you're going to do is you're going to do the square root. So lucky for us, this is an easy square root. The square root of 4 is 2, and the square root of 9 is 3. And so I can do, the square root part pretty easy. I haven't done the power of 3 yet, so I'm going to keep that on the outside. And this will apply to both of these numbers. So I need to figure out 2 to the third and 3 to the third. And 2 to the third is 8, and 3 to the third is 27. And so 8 over 27 is the final answer for that problem. All right, let's take a look at the one right before that on the review, which is question 31. Yeah, anything from the quiz or the test review is fair game for the test. Don't worry, it's going to be, look, right? There were so many different types of problems this chapter. So, first of all, the test review, like, we just threw every type of problem we could find on there so that you would practice everything. The test is not going to be 50 questions long. The test isn't even going to be like, oh my gosh, what 28, the quiz was 28 questions. That was intense. The test is not going to be that long. So I don't, there's not going to be as many problems on the test. That way you'll have more time to do every problem and to be like confident on all the problems. Okay, there's two different ways you can do this problem. So me personally, I like just dealing with them as exponents. It's really important that my big numbers are the same big number. They're both 27. That's really important because my rule says if I have a multiplication problem where the big numbers are the same big numbers, I'm going to keep my big number the same and I'm just going to add my exponents. So in this problem, I'm going to keep my 27s the same and I'm going to add my exponents. This is 6 over 3, which is actually 2, and 27 squared is 729. Okay, so that's one way to do. That's one way to do the problem. Another thing you could do, you could use the rule about exponents that says a fractional exponent turns into a radical. So we could do that also. And so this would be the cube root of 27. This would be the cube root of 27 to the fifth. Since these are both cube roots, I could put them both together. 27, and then 27 to the fifth. This is 27 to the first and 27 to the fifth. So that's 127 plus 5 more 27s. That makes 6 27s. And that becomes, again, 27 squared, which we already know is 729. I like this way better. But this way will get you the answer, whichever one makes most sense to you. 31 on the review. Good. That is thank you. 45 on the review. Where's 45? 45 is another two-part problem. Okay, so the first one says F composite G of X. Who is texting me? Remind. Oh. Alexa, are you still on GVL? No, you're not. Oh gosh, my Alexa thinks that I'm talking to her. I'm not talking to her. Okay, sorry guys. That's the quiz. Sorry, I don't know what's happening here. Okay, sorry, I got distracted. Someone was asking about something else, math related. Okay, so I'm going to take my g function, which is this one, and I'm going to plug it into my f function. So I'm going to put it right here. So I'm going to put negative 4x squared. And then that was being squared, so I'm going to put a square out here, minus 1. Okay, so this is not an adding or subtracting problem. So when you have an adding or subtracting problem that's being squared, you got to write it twice, and you have to FOIL or box. If it's not an adding or subtracting problem, then you can just distribute the square. You could write it twice if you want to, and multiply those together. That's 2 times 2, or 2 squared, and that's x times x, or x squared. But you are allowed to just distribute the square. So I'm going to do negative 4 squared is 16. And then if something already has an exponent, you're going to multiply those together. So that's going to be x to the 4th. And then that's it. We don't want you to factor these. We don't want you, like, we want you to combine like terms and then leave it. So that would be the final answer for that first version. Okay, and then the second one was just backwards, g composite f of x. So this time I'm going to take my f function, which is this thing, and I'm going to plug it into my g function. So I'm going to put it right here. I'm going to keep the negative 4 in front, and instead of the x, I'm going to write x squared minus 1. And since the x was being squared, I do need to square this. Now this time, that is a subtraction problem. So somewhere else you would do like x squared minus 1 times x squared minus 1 again. You're going to FOIL or box. I really, really hope you are capable of foiling or boxing at this point in time. We've been doing it for oh so long. It's going to turn into x to the 4th minus 2x squared plus 1. And then you're going to distribute the negative 4. You always want to do your distributing last after you have after you've done the foiling or boxing. And then this would be the final answer for that second part of number 40, whatever number we're on. What are we on? 45? 45. Okay, Hayden, I know I'm going to skip number 27 because I don't even have enough time to answer the rest of these questions. So I'm gonna do what I can, but I don't know that we're gonna be able to go over all these questions because we're supposed to be done in 1 minute. Where am I? 40 on the review. 40. Okay. Add x plus 2 equals x. So on this one, we want to get the rad x by itself, and that plus 2 is not underneath the rad. So I'm gonna minus that 2 to the other side to start with. And now that the radical is by itself, I can square both sides. And as has been a theme this whole night, you're going to FOIL or box the right-hand side. So write it out twice and figure out what that is. It's x squared minus 4x plus 4. We did a problem like this earlier today from the quiz, and we said that if there's an x squared in the problem, we want to set it equal to 0 so that we can then factor. So I need two numbers that multiply to make 4 and add to make negative 5, and those numbers are negative 4 and negative 1. And so I think the two answers are x equals 4 and x equals 1, but I am not confident on that. So what I need to do next is I need to plug those into the original problem. And so when I plug in the 4, I get 2 plus 2 equals 4, and you know what? Yeah, that works. 4 is an answer. When I plug in 1, I get 1 plus 2 equals 1. That is, oh my gosh, so not correct. And so 1, again, is what we call an extraneous solution. It looks like it's an answer, but it's not really one. And so if this was the test tomorrow, you would only write the number 4 on the answer line. And in your work area, you could do like what I did, where you cross off the number 1 since it is extraneous. All right, Liam, unfortunately, we already did number 9 on the quiz. We actually did another one very similar to number 9. So when we're done, you should be able to watch the video. It should be posted. Actually, it was number 9 on the test review as well. So hopefully you can go back and rewatch this. I don't have time to redo problems because there's already like 4 more questions that I haven't answered. 45, Hayden, we have already done that one, so you can go back and watch the video, but we have not done, so I'm going to do 3 more, guys. I'm going to do number 38, 30, and 39, and then we're going to call it a night. So 38 from the test review. Okay, so 38, a little bit different than the ones we've done earlier because it's not a square root, it's a cube root. So when we have square roots, we square both sides to get rid of it. When we have a cube root, we're going to cube both sides to get rid of it. And so the cube and the cube root will cancel out. On the right-hand side, I do need to actually figure out what 2 to the 3rd power is. That's 8. And then I have my final answer, which is 13. And so just pay attention to if it is square roots or cube roots or 4th roots or whatever it may be. Yeah, you just got to remember to pay attention to the index because that'll tell you what power to raise it to. All right, that was 38. We are on our last 2 problems of the night, 30 and 39, both from the test review. And as soon as we are done, I will do my best to get this posted so that you can watch it. So number 30. Okay, so on this one, I'm going to change this to radical form. Since it's a fractional exponent, it becomes a 5th root of negative 243. And then, as I said earlier, it's in your best interest to put the top number, the exponent, on the outside. I really super duper, with all of my heart, don't want to do 243 to the power of 4. Like, that is crazy insane. And so now I can factor treat. Oh, so one other thing we haven't talked about today, if you have an odd index and the inside number is a negative number, your final answer is just going to be a negative number, and that's fine. It's only when you have an even index and the inside number is negative that you get an I in your answer. So in this problem with a 5th root of a negative number, I'm going to get a negative number when I do this, okay? And then if the negative is outside of the radical for any index, doesn't even matter. That, again, just means your answer is going to be negative. Okay, 243, I will tell you right now, when you factor tree it, you're going to get 5 number 3s. That's just, that it is what it is, or otherwise known as 3 to the 5th. So the 5th root of negative 243 is negative 3, and then I still have this exponent of 4 on the outside. Now, if you're going to type this into your calculator, make sure to type it with the parentheses. If you don't type it with the parentheses, you're going to get the wrong sign for your answer. Remember that negative 3 to the 4th is negative 3 times negative 3 times negative 3 times negative 3, and all of those negatives cancel, giving us a positive 81. The answer to number 30 is positive 81. All right, kids, those of you who are still with me, we are on our last problem of the night, number 39. Remember to check your tutoring schedule to see who's available for tutoring tomorrow. It is not my official day, but if I'm in my room and my door is open, you are more than welcome to come in. I don't remember whose official day it is tomorrow. I want to say it's Miss Kahungu, but check your schedules. because I don't remember. Oh, I don't remember what number we're doing. We're doing number 39. All right. So when you have a fractional exponent in an equation like this, to get rid of it, you're going to multiply by the reciprocal. The reciprocal is when you flip it upside down. So I'm going to make it a 3 over 2. I'm going to put it on the other side also as an exponent 3 over 2. And on the left-hand side, those are going to cancel, leaving me with x plus 1. And on the right-hand side, I'm going to change this to radical form. Now, when I change this to a radical, it turns into a square root. And as we learned in first semester, anytime when you are solving an equation, if you randomly choose to put a square root in a problem, you must have a plus or minus symbol in front of it. And so since this side turned into a square root, I need a plus or minus sign. I need a positive option and a negative option. Okay, so right now I'm just going to kind of try to figure out what that right side turns into. And so the square root of 16 is 4, and 4 to the third is 64. Next I'm going to minus 1 on both sides. And I'm going to put that negative 1 right here because that's the least confusing place I can think of to put it. And then I am going to get two answers to this problem. Negative 1 plus 64 is 63, and negative 1 minus 64 is negative 65. Now, in this problem, there were no variables outside of the parentheses. All of my variables were contained inside of the parentheses. So honestly, I don't have to check my answers. Both of these should work. So 63 and negative 65 are the answers to this problem. You're welcome, guys. So I think I'm going to call it a night because we are past our bedtime. And yeah, that was a lot of work. I'm going to post this as soon as I can. And if you need more help in the morning, if my door is open, I'm here. You can come in or, check your tutoring schedule to see who's available. And good luck on your test tomorrow.